Hello, this is AI Talks, your regular monthly jab of highly concentrated machine learning news. 100% informative and exciting stories on the bleeding edge of ML tools and know-hows from SoftServe. My name is Daniel, and I am happy to be your regular host. And tonight, we're talking about unit tests. Well, I think you all can agree that a good code is something that can withstand the test of time. But the code in a production should also withstand tests made by the developer. And to talk more about how we can ensure that our data science product is 100% working, I would like to invite Svitlana Dubinina, our star data scientist at SoftServe, who's going to talk about data science and unit tests. Hi, Svitlana, how are you?
Hi, Daniel, I'm fine, thank you.
Good. Yeah, so the stage is yours. Please go ahead and let's start.
Okay, great. Can you see my screen?
Yeah, nice and clear.
Okay, great. So, hello everyone. Today I would like to highlight a very important theme, unit testing in data science. Our items which I would like to highlight is the next one. First one is we will talk about artificial intelligence lifecycle. After we will switch to unit testing and model development. I will talk about what is it and what is a test-driven approach to develop effective unit testing. And after we'll talk about testing metrics and artifacts. And the next one will be specifics of unit testing. There we will discuss Python unit testing libraries, fixtures and mocking, parameterizations, and of course summarize our part of unit testing by benefits of it. And finally, we'll talk about unit testing for SQL code. Because data science cooperates with data, and it's very important to understand how to cover by unit test our SQL code. Let's start. The machine learning life is a cyclical process that data science projects follow. It defines each step that and technical teams and business stakeholders should follow to take advantage of machine learning and artificial intelligence to derive practical business value. There are 5 major steps in the machine learning life cycle, all of which have, of course, equal importance and go in a specific order. We can see that on the first step, we need to identify an opportunity to tangibly improve operations, increase customer satisfactions, and otherwise create a value, formulate our problem, and understand on the high level how we can solve it. The next step is functional one. On this step, we need to collect, analyze, train some models, and of course, evaluate. In order to gain insight from your data with machine learning, you have to determine your target variables, the factor on which you wish to gain deeper understanding. It's a main key of this functional step. After we are going to operational step, there is a key role belongs to deployment because model deployment often poses a problem because of the coding and data science experience it requires, and because the time to implementations from the beginning of the cycle using traditional data science methods is prohibitively long. And as a final step, it's a step of interpretations and introduce of our results, insight, documentations of all of our insights, and of course, delivery high quality products. If we dive more deeply to corporations of main teams which interact to data science projects, we can see that we have data science team, DevOps and and ML ops teams, and of course, data engineering. Data science usually cooperates with all of these team members and try to cooperate on each of steps of data science project. The main one, please pay attention that before model deployment, we need to be sure that our code belongs to high quality, and we cover it by unit test. And after, we can start ops functionality and communicate with DevOps about CI/CD process and of course, deployment to production success pipeline. So let's talk about a bit more about unit testing and model development lifecycle. Usually we know that unit testing is a method of software testing that checks which specific individual units of code are fit to be used. The central place of unit testing belongs to, of course, model processing and evaluations, data pre-processing and validation tasks. But a few more additional one, it's interactions with cloud services, AWS or GCP, and feature generations and pre-processing. Please pay attention that under interactions with cloud services, I mean that the process of uploading, for example, some file to S3 bucket, and don't test the connections between your virtual machines and AWS. The next slide belongs to unit test in test pyramid. Of course, we know that the concept of test pyramid, as shown below, introduced by Mike Cohn in his book Succeeding with Agile. Totally, it defines the testing strategy with great visualizations covering the three major types of tests. Unit test, at the bottom, integration test, and end-to-end test. And the proportion of each out of the entire testing strategy is all these three parts. And according to the pyramid, when it is at the bottom, it normally means more isolated and faster tests, other words, cheaper. While moving up to the pyramid, it means more integrated and slower tests, in other words, expensive. And the top of pyramid, we could see manual testing. Eventually, we should cover code with more automated unit tests and less manual tests. Also, we know that one of the effective approach to develop any of the projects is test-driven development concept of software testing, which said us that all products code is written in response to a test case. There are three laws of TDD from Uncle Bob. We know that you are not allowed to write any production code unless it's to make a failing unit test pass. The second one is you're not allowed to write any more of a unit test that is sufficient to fail. And the compilation of failures are failures. And the third one is you're not allowed to write any more production code that is sufficient to pass the one failing unit test. Also, a few improvements after Uncle Bob wrote these three laws. GVR Saldana expresses TDD in two rules version, like write only enough of unit tests to fail, and the second one, write only enough production code to make the failing unit test pass. Logical improvements, I guess. And if we are going to the next slide, we can see our test-driven development cycle. Let's assume that we need to cover by test, and we have some list of methods. We select some functions, and after we need to keep a focus to behavior of one functions, which we will cover by test. And of course, we are going to develop test and run it to ensure that it fails. After we're switching to step develop enough code to make new test and all previous tests pass. If this step is green, we are able to refactor code if necessary to eliminate code duplicates. If we are fail, it's a cycle. We need to come back to fix our test and again develop enough code to make new test and all previous tests pass. This is a very easy example of unit test. For example, we need to write a unit test to validate some functions in Python. For example, it could write by assert functions, assert, call sum, it's our functions which we need to cover. And in the brackets, we set an array from which we need to calculate a sum. In the first line, we can see green label because 1 plus 2 plus 3, it equals 6, it's correct. After double equals mark, we set expected value. And the second line has -1 plus 2 plus 3, and it doesn't equal 6. That's why label red, test will be failed. Unit testing help us to test pieces of code under many different variations, but unit tests are not perfect and it's near impossible to achieve 100% code coverage. We'll see it in practice a little bit later. The next part is testing artifacts and metrics, which usually used in projects. This is a list of testing metrics which possible to use in real projects. First one is code average, is the most useful metric. We also use it by my projects where I participated. The next one is cyclomatic complexity, which is like a number of edges around n plus 2, where n is our number of nodes. Plus 2 is a predefined value. It was burned by experiments of DevOps team. And the third one is test pass percentage. This is a very rare matrix because before to go to productions, we need to test everything on stage, and it might be a case that we don't have passes test cases before we deploy to productions. It depends on projects. And the fourth matrix is build quality, which calculated as the total number of successful build divided to total number of builds pushed. It's also could be applied for production projects, not for testing on stage or test environments. This is a life cycle of functions. So usually it contains implementations and test step, and after test is passed, we are going to accept implementations, and in this case, future request is ready, and we are able to refactor. After refactoring, we are going to the first step, implementation, and after again test. And this flow might be doing more than 100 times. In case if after accepted implementations we find a bug, we need to go to bug fix step and again test, validate our test, it's green or red, and again bug fix or accepted implementations. Is a cycle. It's a cycle, yeah. Such as the number of unit testing is keep growing, we need a strategy to keep all these tests organized. Otherwise, we risk our unit test looking like this closest cabinet. Usually, project structures has the following view. For example, PyTest, it's our name of projects. After we have a source folder, it's all application codes. And after we divided source to data, feature preprocessing, and models. And the next level of the PyTest project folder will be tests, which also contains data, feature preprocessing, and models. For each of subfolders of source, we need to keep the test It helps us to quickly find the required test inside of data or feature preprocessing or modeling, and it will be well organized finally. Also, regarding the structure of test model, we could just put the tests sequentially like this, but this is an organizational nightmare because there is no way to tell where the test for one function ends and another function begins. As we can see, for example, test load data and after test descriptive statistics and test categories variables, test types, test duplication. It might be divided to several parts, and it helps to easy refactor it if needed, and so on. A test class it's another view of how to organize a test model. For example, in view of test class, in this representation, it's just a simple container for test of specific functions. For example, it's get data from CSV, and inside of this class, we can see a list of tests which help us to cover our main functions, get data from CSV. It includes load data, test for load data, test for descriptive statistics, test for categories variables, test types, duplicates, maybe some of the short test for loading correct file might be also included to this model. And finally, project and test structures has the following view. We can see source, and inside of source, it's data, feature preprocessing models. It's all our code of the data science projects. And also we have tests, and inside of tests folder, we have data where all tests covering of data folder contains feature preprocessing the same as we have in feature preprocessing of source folder. It will be just a test for these functions. And the last one, it's models. Models in source, it's code where we build and evaluate the models, and in tests, models for subfolders has tests which cover each of the models which we try to build. And finally, we have that our test directory now is well organized, and looks like we are good with it. Regarding the data science model, usually it returns values which are very hard to compute manually. For example, in case of linear regression, because it performs a complicated linear regression procedures, that's why it's very hard to calculate manually. Which trick we can use to cover our models by unit test is just emulate the output on the high level and try to assert it from expected value. Let me show it in real test project, how it could be tested. Just a second, I will try to share my screen with code. Just a sec. Can you see my screen now?
Yeah, all good.
Great. As I described earlier, we have test projects with source. It's all our code. Inside of this source, we have data, feature preprocessing, and models, subfolders with required code, and we have subfolders of our project folder tests, where I placed all tests which I prepared for this project. And now we are talking about models. For example, let's review. I have XGBoost model because we are trying to solve a binary classification problem. It's imbalanced classification in details, and we are trying to solve it by usage XGBoost model. On this step, we defined all the training and evaluation of this model, and of course, the main one is learning model, where I defined what is XGBoost, what is how I can solve a problem of imbalancing before put data to the model, and how I can evaluate it based on classification report and the final metric ROC-IUC score. How I cover this functionality by unit test, I will open. So I prepared like a tuple of expected hyperparameters, and we have expected report values and expected ROC-IUC. Interesting thing is that exactly I don't know what the model returns. I just know that it returns in some range around. That's why I test each of parameters and say that it will be in the range of, for example, expected hyperparameters and estimators, child weight, gamma, subsample. It will be default input parameters, which I defined very strictly. It's this one. But if we are talking about precision and recall, I just said that it will be more or equals in some value of which I predefine in the expected value, expected report values. This is one of the way how we can cover our models by unit test. If we are talking about, just a second, if we go back to our presentation. If we are going to review how to test the plots, I don't have, unfortunately, an example of how to test the plots, but I need to describe how it's possible to do. Of course, the main thing is to we cannot test figures properties separately because it's very hard, and I guess it's impossible. But we know that there is a few plugins which help us to solve an issue that on one environment figures has one view, but on another environment figures will have another view. From with help of PyTest MPL plugin for image comparison, we will know how to ignore operation system related differences and make it easy to generate baseline images. But let's review a full flow of plots testing. First of all, we need to call plotting functions on the test arguments and convert our result to PNG image. And based on the PyTest MPL plugin, try to compare it with what we received on the implementation step. Implementation step includes, of course, call plotting functions on test arguments, convert our final figure to PNG, and if our image looks okay, fixed plotting functions. Otherwise, sorry, if image looks okay, we receive no, we need to fix it, and after again call plotting functions on test arguments, convert it to PNG format. But if our image looks okay, we will store image as baseline image, of course, with calling our PyTest plugin. And in result, we will have two the same pictures, which help us to validate it and be sure that our plotting functions works as well and as required. The next part belongs to what kind of leaps could be used for unit testing, how can we calculate coverage of our code unit testing, and what is pictures and mocking. And eventually we will talk about benefits of unit testing. Usually there are two leaps which uses in Python for unit testing. First one is PyUnit, and the second one is PyTest. PyUnit has a little bit complicated code, and it needs to import modules, create a class, and define the testing functions within the class. And PyUnit, it's Python's built-in unit testing framework. By PyTest, it's external tool which need to be installed by pip. It has ability to run several tests in parallel. It's fast and efficient, great integrations with various modules. It's very simple, compact, and readable. And of course, it needs to define the testing function separately, not inside of original code. If we are talking about how to calculate code coverage, I need to pay attention about tool coverage. It helps to calculate code coverage based on the count of tests which you developed for each of the functions in your model. Also, code coverage can show which branch in conditional logic are not being covered. It also helps to generate reports in different formats like HTML, JSON, PDF, and others. After all the unit tests are run, you are able to see either in your browsers that exact lines in your code that are being executed, or right in your terminal. Also, coverage has information about lines which was not covered in the report. Very useful tool. I will show how it works practically. The next part is benefit of PyTest. It's a fixtures. In general, it's a functions with decorators that creates a resource and returns it. For example, if you need the same test input for multiple test cases, you can use fixtures to prepare the range step. Just as an example below, for example, I need to have a lot of data in a few tests. In this case, I don't need to call get data from CS3 in each of them. I just need to define fixtures in one place, for example, get draw data, and as a return value, I just called functions get data from CSV, but inside of a test, I just set fixtures get raw data, and it will automatically returns data which I will test and validate by different tests. For example, check shape, not null values, check some categorical columns, and so on. Practically, I will show difference between usage fixtures and not usage fixtures. For example, let me just switch to another screen. For example, we have data, and we have data loading. It's our original code to read the data from CSV file, and inside of test folder we have test data loading.py, and we have a set of functions for check all the loading process. I mean that we need to check shape, not null values, a set of columns, and so on. Without fixtures, every time I need to call read CSV file. So it's this one. Just a second, I will. So without fixtures, I need to call inside of each test regional functions, get data from CSV in this place, in this place, in this place, and it's like code duplicates. And also in this approach, I use parameterization, except of usage a hard code of expected value inside of each test. I suggest to use parameters which returns expected value for each of tests. Some of the expected values should be like predefined before the test in view of, for example, tuple. And each of field has expected value. The name of field should very strictly coordinates with the original name functions, and this is how the test developed without fixtures. If you are talking about usage fixtures, it's very useful. I defined fixtures in one place, and after I just set actual data in view of fixtures, and no need to call original functions in each of the tests. Regarding how to run PyTest, let me show. For example, we need to check all tests inside of data folders. We need to call PyTest, and after pass to our test folders with data, I set PyTest, test, and subfolder data, and just run it. We can see that all our 11 tests are passed. This is great. And a few more specific things in case of if I need to skip something, for example, with a reason that no way of currently testing this, I just add a decorator with pytest.mark skip and set a reason about why I skip it. In this case, I skip it because I'm not sure that the quantity of unique enroll ID is the same as I set to it. Also, it's possible to skip it by technical stuff. For example, pandas is not in sys models. It's just an example, but you can apply it for some specific library, for example, like G++ absent in interpretation library like shape. It will work as well. It helps to run test without focus to failed test and continue work, and after come back to the problematic tests, the unit test. Let's go back to our present. Yeah, it's what I would like to show regarding fixtures. The next part is about parameterizations, which I have already shown in real examples. Let's just summarize it. It extends test functions by allowing us to test for multiple scenarios. We imply adds parameterization decorator and states the different scenarios. For example, I need to test load data, and again, I included to this test validation of shape, not null values, how many missing values, and a list of columns. Inside of hard code, each of these expected values after equals from right. For example, actual df dot shape equals and the list of shape. I just defined expected general info in view of tuple and has a shape field. It has around 20,000 rows and 14 columns. And I set an A columns, missing values, and list of columns in one place. And after I just call this tuple with required field. It helps to have code more readable and easy to interpret, modify in edit time where you need it.
All good.
Okay, great. And the next interesting features is mocking, which is exactly technical that help us to write independent, fast, repeatable test cases. What I mean in this definition, for example, I need to test mean encoding of categorical values in my data science project, but I have dependency about few missing values for my set of categorical values. In this case, if few missing values functions is failed and I have a bug, but I need to cover and go to the next one, it's mean encoding and have green test. In this flow, I need to write a magic mock, which helps me to just mock few missing values functions and just continue testing without focusing on bug which I received in few NA. How it looks like on the practical, let me, as it belongs to feature preprocessing. We have mean, test mean, and I defined it's our expected values in view of tuple, and I defined PyTest fixtures. It has a name of fill NA output. What I did is I just read a file which has output of fill NA function. It helps me to mock it inside of a test which will be cover mean encoding functions. It's my final goal. Inside of test mean encoding functions, I just call fill NA output, which is my decorator, and it returns an output for few NA functions. But main thing is that I don't call original few NA function because I have prepared a file with output for this function. And in result, I can continue my testing without any doubts and can call and code all features and set just a set of the data with few NA. And it helps me to calculate all dependency. I can calculate mean values, assert mean values with min and for. And this is my final goal. Let's run this test, PyTest tests, feature preprocessing, and test mean. So we can see that this test is green, and I'm able to go to the next part. So finally, what is the benefits of unit testing? Of course, it's identification bugs on easily phase, and it's very early phase. Identify bugs easily and early. Of course, we are able to easier update code, push you to have a better structured code, because you will write linear code and prefer to write a code in view of ducks instead of linearly chaining functions when you keep in mind you're going to test your codes with related pieces like a mass of functions in one model, I mean. And finally, it gives you confidence on the output because bad data leads to bad decisions. Running unit tests give you confidence on data quality. You know your code outputs, what you want into output. And before a generate coverage report, you need to run coverage run-m PyTest and set a directory where you would like to run a test. But I would like to run all tests which I have and include it to reports. For this purposes, I run this command, coverage run-m. It helps me to have missing lines which is not covered by test, also reports about it, and PyTest -v W helps me to review all the versions of the tests. We need to wait a few seconds. So now we have a run of all tests which I have, and yeah, we have one failed test. I guess, yeah, it's okay. And now I'm able to generate coverage report. Coverage report, we can see that coverage reports has the name of original model, for example, data loading.py, and it has the number of statements and number of lines which is not covered, and it calculates a percentage of coverage for this model. For example, data loading.py covers covers completely. Otherwise, decision tree model.py covers only for 65% because 15 lines of code were not covered. The same for XGBoost model, it has only 55% of coverage, and it includes 31%. Or 31 statements, sorry. And how to generate PyTest report in view of HTML? You just need to set format in the end of coverage report HTML. We can see that our folder, library developer, 1 second, maybe it's due to that I have this generated. Yeah, probably because I need to drop it. Okay, let's review it, what I received. We just need to open it in the browser. This one would be. Yeah, this is a link to, for example, this one. We can see that coverage is able to highlight the lines of code which is not covered by unit test. It's a normal process that some of the code could not be covered, and it just highlights to pay attention and review maybe some additional test needs, and it will be added to the pipeline. Yeah, and this is how coverage works. If we are going back and talk about our final step, it's unit test for SQL codes. Again, SQL query, it's a language which is used to extract data from database, not only extract, but also read data from database before doing some analysis, before build the models, and so on. A quick tool-free way of doing that could be create a view from SQL query. For example, if we need to select something with conditional personal ID equals to, we just add expect result as a set of these selects and compare it with our original read. Additional approach how to cover SQL code by unit test, it's usage commercial platform like Dataform CLI. This platform helps us to manage data in BigQuery, Snowflake, Redshift, and other data warehouses, and also helps data teams build data pipelines that turn raw data into new tables and views that can be used for analytics. It's a very powerful platform. I highly recommend if you need to cover unit test by if you need to cover SQL code by unit test. And the other free source, it's TSQLT, open source database unit testing frameworks. It also helps to cover SQL code for different database like Postgres. Regarding MySQL, I'm not sure because I don't find in documentations, but yeah, looks like maybe it's possible too. And that's all I would like to show for you today. Feel free to ask me some questions. And of course, thank you for attention.